Yo, 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 welcome back, Math by the Moon. Here to get you guys going on some parent functions. So we're going to start with the square root parent function and cube root parent function along with their domain and range. So you ready? Oh! So here we go. Let me share this out with you guys. So the square root parent function is just the simple square root of x. A lot of times function notation, they have f of x right there. You might think of it as just regular y equals the square root of x. And so when we think about a parent function, we want to be able to plug certain values in, and the values we can plug in are values in the domain. So think back to earlier in the year when we were dealing with simplifying square roots, like breaking it down, factor trees, finding the perfect squares. You weren't able to have a negative in here, and if you did have a negative in there, you had to use an I. So the only thing we can really, quote unquote, really plug in would be anything from 0 on up. So let's just say I plug in 0. What's the square root of 0? Well, that's simple. The square root of 0 is 0. And then I could plug in decimals if I wanted to, but let's just be real here. Let's be convenient here. Let's plug in another perfect square. Like how about a 1? What's the square root of 1? The square root of 1 is 1. And again, I could use numbers in between 1 and 4, but I don't really feel like plotting because we're eventually going to plot the points. The square root of 4 is 2. And the square root of the next one I would use would be 9. The square root of 9 is 3. And square root of 16 would be 4. Now, these are all the input values, and there's values in between 0 and 1 and in between 1 and 4, decimal values and such that we can also plug in, but we can't plug in negative numbers because you can't do the square root of a negative, so those would be imaginary. So the domain values for this situation would be all x's that are greater than or equal to 0, because we can't plug in negatives. And our range values, the range are what you get out. The range are the y values that you get out from the corresponding domain values. So the range would be anywhere from 0 on up as well. So the y values have to be greater than or equal to 0. So this is your domain for a parent function for the square root, and this is your range. And when we look at the graph, you're going to see that it never goes below 0 left to right, and it never goes below 0 vertically, meaning the y values are always from 0 on up, and the x values are always from 0 on over. So let's take a look at that. So we have the point 0, 0. We have the point 1, 1. And we have the point 4, 2, and the point 9. Whoops, that one was at 9, 2. I need to go to 9, 3. And I could go 16 and 4, right? 16 would be out here and 4 would be up here. But the bottom line is I don't have a big enough graph. So then we sketch this curve here. And bear with me, I'm using the trackpad. And it just kind of looks like this flattened arc, right? A flattened arc. It's sort of smooth, but not linear, okay? It's kind of like, ooh, like a curve. Now, again, like I said with the domain, it's never going to be to the left of 0, 0, right? It's never going to have any domain values over here. You can't plug in -1, -2, -3, and so on into the square root. And you'll never get a negative result either. When you do the square root, you get a positive answer. So you're not getting anything down here either. So it's just from there on over. So that's your square root parent function. Again, the domain is x is greater than or equal to 0, and the y for the range has to be greater than or equal to 0. All right. I hope this helps with the square root parent function. So if that helps you with the square root parent function, great. Talks a little bit about domain and range. Let's get into the cube root parent function. So in the cube root, you have the potential to plug in any real number you'd like, positives, negatives, or zero. So let's start with the easy one. Let's start with 0. The cube root is 0. And I like to put it in the middle because you can plug in negatives. The cube root of 0 is 0. The cube root of 1 is 1 times 1 times 1. The cube root of 8 is 2. And the cube root of negative 1, you can do this, negative 1 times negative 1 times negative 1 is negative 1. The cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2. Now, what this means is I can really substitute any number I'd like into my domain value, into my x. So the way that Edgenuity writes it is they say that the x's can be anywhere from negative infinity to infinity. And I like to say, like MC Hammer, you can't touch infinity. Can't touch infinities. So we say that we are always less than, but we can't be equal to infinity. Or greater than, but we can't be equal to negative infinity. And I don't put the line under it because you can't touch that one. Okay. And that just means that I can plug anything I'd like in here from negative infinity to infinity. And additionally, that gives me any output I can possibly imagine. My outputs are positive, they're negative. And to be quite honest with you, they could be decimals if I plug in the numbers in between here. I just use the perfect cubes. I just skipped around from 0 to 1 to 8 because they're the perfect cubes. The next one I would have used would have been 27 and negative 27 because that's the next cube in line. But anything in between there will also give you a decimal value in between. Like let's say the cube root of 6 is somewhere in between here. So it'd be like 1.3 or 1.5 or whatever. So our domain is anything we'd like to plug in. Our range is also anything we could imagine to get out, because we can get positives and negatives and decimals out. So it's the same thing for our range. So from infinity to negative infinity. And like MC Hammer said, you can't touch this. And what I mean by that is I don't put the line underneath for less than or equal to or greater than or equal to. Okay, so that's your square root function, or your cube root function rather. Let's take a look at what it looks like as a graph. I already plotted these points for us, and you can see it'd be this like smooth little flat curve, okay? Similar to a cubic, but just kind of leaned over on its side. Like you remember cubics went up on the right and down on the left. Well, this one just kind of laid over, and now we got, I have a very bad trackpad here, but it would kind of go like this and like that, and just kind of easy on its way over. So hopefully this gets you an idea about what the parent function is. It's the cube root, we use perfect cubes to plug in. We can plug in positives and negatives, and we get out positives or negatives. So the domain and the range is literally all real numbers, from negative infinity to infinity. With the square root, we saw how you can't plug in negatives. So your domain is all numbers greater than or equal to 0. And this time you can plug in 0. So you want to put the line underneath it. You can touch 0, right? That's a solid plot point right there, 0, 0. So I go greater than or equal to for 0 for x because I can plug it in. And for y, same deal. I'm greater than or equal to 0 for y. I'm never going below. I'm never getting negative y values out. All right, so hopefully that clears up the parent function. For square root, we use perfect squares, can't use negatives. For cube roots, we'll use perfect cubes, and you can plug in positives or negatives in there. Hit me up if you need any more information on the parent functions and their domain and range.